All right. So everybody has your notes. Notice at the top it says inverse variation. Inverse variation. Yesterday we did direct. Today it's inverse. Okay. We're going to do the steps just like we did yesterday. And I'm going to stress to you guys, if you don't, make sure you follow step by step by step. I worry that you'll really struggle. So please follow step by step by step. Okay, so a function of the form. Now there's two different ways that this can be written, and we'll talk about why that is. What was the form for direct variation? What's the y equals kx? Okay, so for inverse, instead of y equals kx, no, it's xy equals k. Xy equals k. So what does that xy mean? What's that operation that we're doing? Multiplication, right? So we're going to write it, though, when we, in our step 1, we're going to write it solved for y. So what does that look like if I solve for y? No, I want y equal to something. Y equals k over x. To solve for y, you need to divide by x on both sides. So when you do that, it looks, like Jordan said, like this. Y equals k over x. And this says where k equals 0, that should be not equal, where k does not equal 0. So make sure you put a line through your equal sign there. It is not equal 0. So a function of the form xy equals k, or we will use it, we will see it and write it y equals k over x. But we want you to see that that's where that came from, okay? Where k equals 0, does not equal 0 is inverse variation. The variable k is called what? It's the same as yesterday. What's the k equal, guys? There you go, thank you. Constant of variation. In inverse variation, x and y vary inversely. Remember she was saying yesterday, when you see that word directly, it should jump out and smack you in the face. Today, you're going to be slapped in the face by inverse. Okay?
Well, I got 2 restraining orders.
So this means that one variable increases and the other one decreases. Just like the examples on the board. While one increases, the other one decreases. Examples. So look at that chart, guys. Let's look at your x values versus your y values. You've got x in the first column, x is 0.2. And in the second column, y is 12. In the second column, x is 0.6 and y is 4. And in the third, x is 1.2 and y is 2. So what's happening to our x's? Well, they're increasing, more vaguely, they're increasing, right? And what's happening with our y's? They're getting smaller and smaller and smaller. Now here's the question. Does that alone make this an inverse?
Yes, actually, because one's going up and one's going down.
One is going up, the other is going down.
You have to check to see, but yes.
You have to check what?
Like, this, for yesterday, you had to check between the first one is X, the first one is Y. This one you check, the way I did it is 0.2 times what, or like 0.6 divided by 0.2.
Do they vary by the same constant?
Yes.
That's the constant of variation, right? Do they vary by the same number? That's what you need to know. So you kind of have to know two things. Number one is one getting bigger and one getting smaller, but then you have to figure out, do they have the same constant of variation? That is important.
Like you mean like the entire thing? Or?
Yeah, all scenarios. So we need to check the first column, the second, and the third. So looking back up at the first part of your notes here, how can you tell if they are varying by the same constant? How are we going to be able to tell if these vary by the same constant?
Dividing y by x.
Maybe y by x. I think that's what we did yesterday, didn't we? To find the constant of variation. Try it and see. Let's use your calculators, guys. See if you can figure out how to do it. Does each column have the same relationship? Same constant of variation?
The way I did it like,
I think it's
I
supposed
saw
to multiply.
12, 4, and then 2, so I'm like, 12 divided by 2 is 4, and then 4 divided by 2 is 2. And sometimes 2, or 0.0, 0.2 is multiplied by 2, 0.6, and then 0.6 multiplied by 2 is 1.
So it's not that if you no, that's not.
It's not the same, but between 0.2 and 0.6 and 3, and then 0.
You can't. We're not looking at x to x. We're looking from x to y. Jack, are you onto something?
Were you supposed to multiply it?
Multiply what?
Multiply 12 by 0.2 or divide it
What do you get when you multiply 12 by 0.2?
by 2.4.
You get, so guys, when you multiply 12 by 0.2, you get 2.4. What do you get when you multiply 0.6 times 4? 2.4. What about the third one? 2.4. So we're multiplying x times y to get our constant of variation. Makes sense, doesn't it?
I did
Exactly.
that for this, and I got 4.8.
You multiplied what times what and got 4?
Times 2.
0.2 times 12.
Yeah.
Put it in your calculator. 0.2 times 12. What do you get?
I think I might have missed it.
I think so. So Javi just said that means that 2.4 is our constant of variation. Well, that makes sense because x times y equals k. So that's how you find out if these guys, if this relationship between the variables is an inverse variation. So is this one?
Yes.
Yes, it is. Yes. How do you know? Number one, first of all, as x gets bigger, y gets smaller. And every time we multiplied x times y, we got 2.4. We get 2.4. So the first kind of little test would be, is one increasing and one decreasing? If one's increasing and the other one's increasing, you know it's definitely not going to be inverse. So that's kind of your first test, but that doesn't alone tell you if it's indirect variation, or excuse me, inverse variation. Is it ever called indirect variation? Indirect. Yeah, I like inverse, less confusing. So we need to write the function to model this relationship.
For the function, we have to write the
No. Mm-mm. And in fact, that's why I kind of drew this, it's this one. So what is that, what's the function that models this relationship? Yep. Y equals 2.4 divided by x. Good.
I put x times y equals 2.4.
So you're going to use it in this form, Jack. Okay, so let's take a look at the next one, at number 2. So let's kind of do the first little test on it. Are x's increasing or decreasing? They're increasing. What about our y's? They're decreasing. So, okay, it passed the first test, but that's not the only test we have to give it, right? What do we need to do? What's that? For all 3 columns.
They don't equal.
No?
1.5.
Okay, so this one, 1 times 2, that's 2. 2 times 1, that's 2, but that's 1.5.
No, they are not a relation inverse.
Good. No.
So if it fails out one test, it's no.
If it fails this test right here, it's a no.
Sorry.
The constant of variation is not the same for all points.
How would you write these out, like for number 2, or number 3? How would you write that out?
For the next one,
Yeah, because I mean, like, I don't know.
okay,
It's weird.
all right, so this is, again, in yesterday's notes, we had a table, right, to start, and then we moved into word problems, right? So we're going to have a step-by-step for how to do these word problems, okay? Just like we did for yesterday's notes. All right, so this should be number 3, not number 2.
And the next one should be number 4.
Yeah. Yeah,
And so on.
and so on.
I'm real good at that.
It's all right.
It's
So,
fine.
all right, so listen. If y varies inversely as x, what's slapping you in the face there? Inversely. Inversely. If y varies inversely as x, and y equals 3 when x equals 4, find y when x equals 18. So let's write out the steps.
It would be, I'm not trying to look at class notes, I'm trying to remember.
What do we think? What's that? No, we're going to use
Oh,
this one. It's just to show you where it comes from, where this comes from, because we multiply x and y to get k, but when we solve for y, because anytime you see an equation, we're always solving for y, solve for, y equals something, right? So like y equals mx plus b, y equals ax squared plus bx plus c. It's always y equals. So that's why we show you this to show you where it comes from, but this is the equation that we want you to use, okay? Yes, Alex?
If I try it,
Pardon me?
if I try this,
Well, hold on. We're going to talk about the steps. What's step 1?
so I'm guessing it's like backwards from what we do before.
Wait. Step 1 is what, Kayla? Write the equation. What's the equation? We write-
y equals k, or x, y.
Y equals k over x. So step 1,
Wait, why can't we use X, Y?
y equals k over x, because this is inverse variation. Oh, why can't you use this? Because we did this to show you where it comes from, but this is how we want you to write the equation.
Oh,
That's why I did the little around it.
oh.
Step 1, write y equals k over x.
Wait, why are we writing this in number two?
Pardon me?
Why are we writing this in number two?
I'm just writing the steps, on, just so I can have it somewhere,
Oh,
because we're getting ready to do these steps in number 3, okay? So this is steps. What's step 2? Plug in your x and y values. Okay, what's step 3? We'll do the steps and then we'll go solve for k. Good. Step 3, solve for k. What's step 4? Exactly, and that is, guys, when the problem asks you, write the function to model this situation or this relationship, this is step 4. Plug k, or I guess rewrite the equation with the k value.
That's all for the other variable. Right.
Yep. And then the last one, solve for the other variable.
You all right?
I'm good, thanks. All right, so now we've got our steps right there. Let's do number 3. If y varies inversely as x, that tells you this is the equation we're going to use.
Yeah.
If it's, what if this said if y varies directly?
Or
KX.
Right, we would use y equals kx. Because it says inversely, we're going to use y equals k over x.
So that'll be
So step 1, y equals k over x. Step 2,
It would be 3 equals k over 18.
3 equals k over 8, over what?
That's an 18.
Yeah, no, not 18.
Okay.
Look, read what it says. Y is 3 when x is 4. Y is 3 when x is 4. Okay, so make sure you grab the right kx value, rather. So number 2 is 3 equals k over 4. Because we're going to solve for k. So step 3 is you're multiplying both sides by 4, because we've got k divide by 4 to get k by itself. Inverse of division is multiplication.
So that'd be 12.
So times 4 and times 4. 12 equals k.
And you plug it back in.
So now you're going to, step 4 is important. You're going to rewrite this equation with the value we found for k.
So that'd be y.
Why don't you, it says rewrite the equation with k, and
12
then
over
why don't you write it like y equals 12 over 18? Because that way it's,
It's not an equation.
but,
So you can put something in.
The step is, because if it said, if the question was write the function to model this relationship, you wouldn't write y equals 12 over 18. You would write y equals 12 over x, yes?
An equation has an x and a y in it, and you're already substituted in, so you're getting a value.
Austin?
I think I got this.
Why is the y 3? Like in 4, why did you put 3 instead of y?
That's the first one.
Because step 4 is to rewrite,
So we don't rewrite
Except
the
to-
y?
say what?
So we don't rewrite the y?
Are you talking about step 4, right?
Yes, step 4. We don't rewrite the y.
We do rewrite y equals
No, but you see,
12 over
in
x.
the question it says y equals 3. Why wouldn't we put 3 there instead of? What line in my language?
Because,
Two different problems.
But you already did that in number 2, step 2.
so guys, it's really important that y'all understand that step 4 is you are actually writing the function that models the situation we're presented with. Okay? So it's y equals 12 over x.
So remember yesterday when we wrote the equation on, it was the last one that we did and graphed it? If you don't write a y and an x using a k value, you can't graph it. So you've done all of the work to find the k value, and then you're going to put it back in an equation. So if you wanted to put it in your calculator, you could. But that is a crucial step there, okay?
So this is the function that models this situation that we're talking about here. Okay? So now we're going to do the very last part, which is find y when x is 18. So we've got to find y when x is 18. So take your 18 and now put that in here. That's step 5.
I know what to do now, Mitch. Then you just simplify it.
Yes, you do. You math bracket, and what do you get?
4/6 and then 2/3.
So 2/3.
That's what y is.
So that is your answer.
I wasn't sure if it was right, but I guess it was.
Good. All right.
Wait, how'd you do that? How'd you simplify it?
Math, just 12 divided by 18, math frac.
Okay,
Okay, can we go on to the next one?
yeah.
Guys, step by step by step. Steps are the same. There's 5 steps in yesterday's and 5 steps in today's. All right, this is number 4. Given that x and y vary inversely, write a function that models the inverse variation when x equals 7 and y equals 2. So it says write a function that models the inverse variation. Okay? That's step 4. We need to go all the way to step 4. All right. Given that x and y vary inversely, write a function that models the inverse variation when x is 7 and y is 2. Step 1 is?
Y equals k over x.
Yep. And we know it's y equals k over x because it says inversely. Because if we mix these up and do yesterday's and today's, that's really important. What you put in step 1 matters based on what this word says, if it says inversely or directly. Okay, step 2, let's plug in what we know. We know that x is 7 and y is 2. So, Yep. 2 equals k over 7. What's step 3? You're solving for k, so you need to multiply both sides of the equation by 7. Good. So step 3, we're going to say 7 times 2, that's 14, equals k.
That's it.
Step 4, rewrite the equation with your new k value. Rewrite with the k value that you found. So y equals 14 over x. That's it. You're done. Because it doesn't say find x when y is blah, 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 right? It just says write the function that models this situation.
Find y when x is blah, blah, blah.
Yeah, whatever, yeah. So that's it, guys, you're done. Get to step 4 and stop. Questions about that?
It's so easy. I know.
Does easy use them?
Yeah.
Yeah.
Simple. Pretty simple.
All right.
Are you gonna do it by yourself or are you gonna?
We'll have you guys do a couple. Okay, this should be is this number 5 now? Yeah, so this is number 5. All right, guys, here's like a real world, this is a real world scenario. The time it takes to pedal 20 miles varies inversely with the rate at which you pedal. Finish the table given and sketch a graph of the situation. How long would it take you to pedal 10 miles per hour? A lot of words there. A lot of words there. So let's kind of break it down and make notes like we were doing yesterday. So, what's that? Because the phrase is, if y varies inversely as x, if y varies inversely as x. So as I say that, as I read this, as y varies inversely with x, the time it takes, so that's going to be our y, Kayla's right, that's our y. So time, write a little y above that so you know, as y varies inversely as x. So time is y, what is x?
Pedal.
The rate. Good, the rate. The time it takes to pedal 20 miles varies inversely with,
The rate.
so write an x above rate. Now we have to finish the table given and sketch a graph. So look at our, the rate is our x, right? So I'm going to write a little x above it just because I can. So look at the rate. What is it doing? 2, 4, 5, 10. Increasing or decreasing? It's increasing. So what should my y's be doing? They should be decreasing. Okay, kind of keep that in mind as you're doing these. Okay?
So what do they decrease by?
Well, we're going to find out. So, step 1, write the equation. Y equals what?
10?
No, what's the equation?
K over X.
K over X, thank you. Yep.
So now,
Step 2, plug in X and Y. So, let's look back at the problem.
4 equals.
Okay, no, I'm sorry. We got to look at the table.
Yeah.
We got to look at the
So
table.
it'll be 4 equals.
Well, we got to plug in both values that we know so we can find K, right? So let's start with the first row.
Oh, wait, no, wait. It would
K
be,
over
2 and 10, yes?
it would be 10 equals.
So then you multiply the 2 and get.
Wait, hold up. We're still doing number 2. We're not on 3 yet. So Y is 10
Yeah,
and X is 2.
yeah. So it'd be K over 2.
So 10 equals K over 2. Step 3 says solve.
So that'd be 20.
Linda and Brian, y'all paying attention?
That'd be 20 equals K.
So we need to solve. So multiply both sides by 2.
Yeah,
20
equals K.
equals K.
Then you come back to it.
So that's my constant of
Now
variation.
that'd be Y equals.
Oh, I thought we were both.
That's not what I heard either. Yeah.
Okay, step 4, rewrite. We're going to write the equation that models this situation. So step 4,
Y equals 20 over X.
yes, good. Y equals 20 over X. Okay, so for step 5, what do you think? What would you plug in?
Plug in 4, 5, and all.
You'll have to do all 3. So you got to plug in 4, find your Y. Then we'll have to do 5, find our Y, and then 10 and find our Y.
So you just math bracket, right?
Well, there is.
Well, hang
but
on.
You gotta plug it all up.
We'll have to do 3 different ones now. So 5, plug in what you know. So for the first step, for the first Y value, we plug in 4 for X. So Y equals 20 over 4.
That'd be 5. Okay.
And then, so, Y equals 5. Yep, good.
Well, wait
do I draw the arrow?
Say what, Kayla? Is it? So, oh, okay, I didn't notice that, yep. So when x is 4, y is 5. And then y equals 20 over 5. You get y equal to 4.
So 10 equals
And then y equals 20 over 10. Y equals 2. So my x's all increased. Are my y's decreasing?
Yeah.
If they weren't, that would be a huge red flag, right? So we finished the table, and now we need to sketch the graph.
Man, that's so lame. Not the graph.
What's lame?
The rate mile per hour is 2, 4, 5, 10, and the
so
time is
bad.
10, 5, 4, 2.
So let me ask this question, okay?
It's going backwards.
Does it make sense? Let me ask that question. If I am pedaling, guys, at a rate of 2 miles per hour, it takes me 10 hours. If I'm pedaling at a rate of 4 miles per hour, it's taking me 5 hours. Does that make sense? The harder I pedal, the faster I'm going to get there, right? The sooner I'll get there. So that does make sense.
I thought that was how many miles you have left.
What if you're going
The rate?
No, yeah, that's miles per hour. What's that?
What if you're going
It goes both ways?
I mean, again, this takes out all variables, right? It'd be on a flat surface. All right, so we need to graph this.
My bad, I just go down. I go up there.
Like 2, 10, 4, 5.
Oops,
And you
oops,
just
oops,
plug
oops.
in your X, Y, and none of these are negative, so they stay on positive. Alright, and these look like this.
All right, so 210. Right there. And then 4, 5. 5, 4. And 10. 10, 2. Right there. So let's go ahead and connect these points. Is that linear? Hmm? Mm-mm. Nope.
Wait, it's going both ways?
Hmm?
Right angle?
Yep, it goes, yeah, it's going to go infinitely this way
Okay.
and infinitely this way. And we'll talk more about what these are called.
My line came out super curvy, I don't know why.
Does it look sort of like this?
You know, like with the, you know how you did the X thing? Well, somehow my line went.
Uh-oh. Maybe you plotted a point wrong?
No, no. You know how you did the X things for like the lines, right?
Uh-huh.
Well, somehow my reason on my line for the X for the line went like.
Oh, okay. User error. All right, guys, let's look at the next one. So as I read this, I'm going to label the actual word problem. The number of songs that an iPod can store varies inversely with the average size of a song file. The number of songs that an iPod can store varies inversely with the average size of a song file. Which is my X, or which is my Y, rather?
The number of songs.
Number of songs is my Y.
Yes, ma'am.
And what is my X?
Uh,
The size of a song file, right?
so,
If you're not labeling the word problem with your X and Y, I feel like you will really struggle.
Is Y up?
Huh?
Y is up?
Number of songs, number of songs. Number of songs. Okay. An iPod Touch can store 2,500 songs when the average size of a song is 4 megabytes. So an iPod Touch can store 2,500 songs. What is that? X or Y?
X. I mean, Y.
It can store 2,500 songs. That's my Y. So let's go ahead and write a Y there with it. When the average size of a song is 4 megabytes. That's my X. Let's write an X above that. That way, when we pull information to plug into our equation, we know exactly where to go to get it, right? So let's stop here before we finish reading and go ahead and start step 1. Y equals K over X, because of this right here that jumped out and slapped us in the face inversely. Y equals K over X. Step 2, let's plug in what we know. That's where we're going to pull this, our X's and our Y's here. So 2,500, good, equals K over 4. To solve for K, that's step 3, is solve for K, right? So what are you going to do? Multiply by 4 on both sides, good. So times 4 and times 4. So that's 3, what is it? 10,000. That's my constant of variation. Step 4, we're writing the function that models this scenario. So that is Y equals 10,000 over X. Okay, but now let's go back to the problem. It says find the number of songs that can be stored if the average song is 8 megabytes. So what is that? The 8 megabytes. That's our X. So our unknown is this right here, the number of songs, right? So I'm going to put a Y there because we don't know it. We have to find it. So in 5, we don't know Y.
Oh, 10,000 over 8. Need the math bracket, right?
Yes. Good.
I got 1,200.
I got 1,250.
1250 is what you got, Austin? Good.
That equals Y, right?
So Y equals 1250. What does that mean for this particular problem?
That's the number of songs that can be stored.
Yep. So 1250 songs. 1,250 songs.
Wait, wouldn't higher megabytes mean you could store more songs?
The higher megabytes, it can hold less songs with more megabytes. Less songs with more megabytes. Because this is inverse.
Yeah, that's.
Does that make sense?
So you're saying 1 megabyte would be able to hold
More songs, right? Yeah. The smaller the song size. No, this is song size.
Oh, okay.
Song size. So if I have a movie,
Yeah.
the movie's going to be huge, right?
Yeah.
So I'm going to be able to store less movies
Yeah.
because they're so big. Does that make sense, Jack? Okay, so look.
I don't understand.
I got it.
Yeah,
You got it? Okay.
but think of it as like a process of like elimination. Once you use it, so
Anybody else confused about this? Does this make sense? Your little shuffle, if you got little bitty song clips, you can hold a bunch of those, but the bigger the song size, 8 megabytes, you're not going to be able to hold as many. All right. Why don't you guys try number 6? Yeah. Yeah, hurry. Leave your phone and hurry back and get right back to work on number 6, okay? Because I really want you to try number 6.
No, I was actually just confusing like the I think I thought the megabytes was stored.
Because the shuffle holds the same amount of storage.
I thought the megabytes was just like storage, trying to hold not the size of the song.
All right, you guys are trying number 6. Try number 6. That's okay. How many do you need? What's 6.5 hours? That's good. Hey guys, in number 6, it uses V and P, I think. You can interchange Y and X if you want. So V is Y, P is X, right? So I would write it on that. So there you go. That helps you do that, doesn't it? So then what is this?
Oh, that's right.
Volume? Volume is?
Oh, wow.
Uh-huh. So yeah, and what would that be then? So then let's stop there, okay, and go ahead and get your, get to step number 4.
Skip 2.
No, we'll go ahead and do 1, 2, 3, 4, and then move to problem, okay? Yeah, why? You in a hurry, you gotta be somewhere or something? Come on, you guys are doing number 6.
I'm done.